I'm Jonas Bassett, and this is our engineering design and development prototype for a better desk for the school classrooms. As you can see here, the primary material is cardboard, though we do use, of course, some tape and wood in order to keep it up. Through our designing process, we've learned a lot of things about desk creation, and particularly weight distribution. So first, let me show off the central feature of this here desk, that being its adjustability. Through these somewhat basic holes in the sides, we can get a pretty rudimentary and standard adjustability system. As you can see, I remove this, I move it down. Once the holes line up, I put the stick back through, and bam. Now I just go over to the other side, repeat that same process. And my desk is higher than before. This allows for students of varying heights and sizes to be able to use the same basic desk model. No matter how short you are, no matter how tall you are, you should be able to use this. Particularly, one of our main goals was to get this to be a standing desk, as you can see in its current configuration. While we were building this, stability was our main challenge. To increase stability, we added some supports on the legs. We also added this piece in the center. You can see with other common desks on the market, which we found in our research. Overall, one of the primary things we realized we needed to be focused on, aside from our primary goals, was support. Because no matter how good your materials are, if they can't hold themselves up, there's no point in building the desk in the first place. One of the other accessibility features of this desk we made is a sort of sliding piece. Now this is a very microscopic miniature version of what we could theoretically construct. But with little imagination, imagine this as a larger side piece to the desk. Something like this, with its whole own work area, which opens up brand new possibilities for efficiency. You can move it side to side. And if this was the entire desk space, whether you're right-handed or left-handed, you could put it on the side that's best for you, or to whichever configuration suits your fancy. You can see we have a mechanism that we're actually going to use in our final design to more adequately show what we're trying to do. Of course, I understand that this adjustability is somewhat lackluster, so we've been exploring a lot of options. I'll now hand it to another one of our team.
So for our adjustability, originally we were thinking of using tension springs between the inner parts of the leg, to where when you lift up the table, the tension springs will bring it back down. But instead we realized that that's quite the issue, as there was no way to efficiently use that.
The primary issue with this is we intended on using some kind of crank to where as the string gets pulled up, it wraps around the crank, and these springs are in turn also pulled up. The issue that we realized, though, is that as the strings are pulled around the crank, as there becomes less string distance, there becomes more spring distance, which meant that the distance stayed virtually the same, and there was no adjustability to be had. After thinking a lot about ways we could change this and make it work better, we ultimately decided that compression springs would create a easier to manage and just better concept overall.
So instead we came up with this kind of mechanism. The idea here is that a gear in the middle would turn counterclockwise, and 2 gears on the side with bike chains around them would also turn with them. But because of it being 2 gears, one would be turning the opposite way that the other one turns. So these two would be turning all as one to pull up the bottom anchors of the leg. On the innards of the leg, there would be compression strings. So then as you would turn the mechanism, it would make the legs go higher or the desk go shorter. And the compression springs, once it's unlocked, would have enough force to beat the counteracting force to push away the desk. That was just one of the few issues that we've noticed. Of course, there was stability, and another one of the issues that we noticed was that like how you would notice on the moving of the prototype, the legs you'd have to adjust one and then adjust the other. So if you adjust one like this, it would be lopsided like so on. So we also need to figure out a way to move both legs at once, which is why this mechanism is centered around the one piece in the middle.
This is our prototype.